Good morning, good afternoon, good evening, everyone. Thank you for joining us today. Welcome to this webinar, part of the ongoing series hosted by ISO Technical Committee 347, Data-Driven Agri-Food Systems, as part of our commitment to transparency, engagement, and inclusive participation in the standards development process. ISO TC 347 is a relatively new and very ambitious committee working to develop international standards that enable trustworthy, inclusive, and effective use of data across agri-food systems. My name is Andres Ferreira. I'm the chair of TC 347, and I'll be your moderator for today's session. Our webinar series is designed to explore key technical areas where standardization can support innovation, sustainability, and interoperability in agri-food systems. Today's topic is Clarity Counts, the value of representing modes of action and formulation codes with controlled vocabularies. To give you some context, pesticides are used widely in modern agriculture and in increasingly complex ways, for example, using drones and spot spraying robots. Helping farmers use chemicals accurately and safely in compliance with their legally binding label affords a valuable opportunity for information technologies to support decision making. Managing digital tools to support responsible pesticide use for millions of growers worldwide requires standards, however. And so our speakers will introduce two standardization opportunities under consideration in TC 347, modes of action and formulation codes. In this session, we'll describe the importance of modes of action and formulations for plant protection products. We'll discuss their relevance and use in the context of digital labels. We'll share a simple proposal for related action within ISO TC 347, and we'll show how you can actively participate in shaping upcoming international standards like these. Let me introduce our speakers. We're very fortunate to be joined today by Sarah Hovinga and Graham Mullier, who will lead us through the discussion. With 20 years of diverse experience in biopesticide and agrochemical R&D, Sarah Hovinga focuses on advancing regulatory policy in digital agriculture with an emphasis on precision application of pesticides, including advanced application equipment, drones, and digital labeling. Sarah studied biological sciences in Spanish, and her master's degree is in biochemistry. She co-chairs the CropLife America Drones Working Group and is vice chair of the Unmanned Aerial Pesticide Application System Task Force. She also participates regularly in emerging technology forums at CropLife International, CropLife America, OECD, CIRSA, EPA's Pesticide Programs Dialogue Committee, the American Chemical Society, and the American Society of Agricultural and Biological Engineers. Sarah lives in Sacramento, in California, with her husband and young daughter, and is an avid gardener. Regarding Graham, he was originally trained as a natural scientist and computational chemist. He has over 3 decades experience working within crop protection R&D as a data and IT specialist. He's run teams specializing in software architecture, research informatics, data visualization, and data science. Working with a number of external collaborations, especially in recent years, has brought a focus on digitizing product information. His work contributes to a growing data ecosystem for digital agriculture with projects on data models and data standards. So let's get started. Sarah, you have the floor.
All right. Thank you so much, Andres. And it's a pleasure to be here with you all and with my co-presenter, Graham. We look forward to walking you through, as Andres said, the importance of mode of actions and formulations for plant protection products. So we wanted to talk a little bit about what they are and give some examples. Graham will then go through some of the user experience with mode of actions and formulations and how they're appearing on product labels. We'll talk a little bit about this opportunity for these different elements to be used as reference data standards and how this fits into the work that Andres described of TC347 and Working Group 1 first, and to have a little bit of fun with it, hopefully, in terms of talking about a use case and how these are fitting in. We wanted to tell a little story about bananas and give examples of modes of action and formulation within this important crop. So bananas, maybe some of you have been eating some bananas for breakfast today, or will have one in a smoothie coming up, but are a very important food for global food security worldwide, being a staple food for over 400 million people and are the fourth most important crop behind rice, wheat, and maize worldwide. They're very nutritious and also offer an income to smallholder farmers that are trading these crops. And on average, over 90% are exported from Central and South American regions, the Philippines, and are largely being imported into the EU, the US, China, Russia, and Japan. So the crop is important. However, it is susceptible to pests and fungal diseases. And just giving a couple examples here on the left, you see a leaf spot disease called black sigatoka. On the right, you see soil disease coming from fusarium, and the disease is called Panama disease, which infects the pseudostem. And both of them are very detrimental to banana yield. And then on top of this, you also have the effects and extreme weather events that we're seeing more and more from climate change, which is really making banana production increasingly difficult and potentially disruptive to this important food supply worldwide. This wouldn't be the first time that fungal diseases have caused a massive disruption in the past. Not outside of bananas, many of you have heard of the Irish potato famine that was also caused by a fungal disease called Phytophthora and was obviously very detrimental. Bananas face this same risk. So you see on the left here, the Gros Michel cultivar variety of bananas, which was the most dominant exported cultivar of bananas prior to the 1950s. I actually still have it on my bucket list to be able to try this one day, but unfortunately, it's not the dominant cultivar anymore. And now, what you see in the store is the Cavendish cultivar. And what happened? So to the Gros Michel. So during the 1950s, an outbreak of Panama disease almost totally wiped out the Gros Michel banana production. And as I mentioned, it was the dominant cultivar from Fusarium wilt. And so that inflicted enormous cost and forced producers to switch to other disease-resistant cultivars. For those of you history buffs out there, luckily the sixth Duke of Devonshire, he was around until 1858. William Spencer Cavendish, he was a plant lover, had a new cultivar in his greenhouse at Chatsworth House in the UK that was resistant to the strain of Fusarium that caused the Panama disease in the Gros Michel cultivar. And so that's what gave us our Cavendish variety that we have today. But unfortunately, you've probably heard of a new variety if you're following the banana trade at all, a new variety of Panama disease caused by a new strain, tropical race 4. And so that is now threatening our Cavendish production today. So we still need to keep an eye out for it. This is bringing up right, the topic of resistance. And so fungal diseases develop resistance to plant protection products. And what's happening? So this is happening when the disease is essentially learning to survive of fungicide treatment. And so, fungi are reproducing very quickly, especially under ideal conditions. And each time a fungicide is sprayed, most fungi are killed, but a few may have naturally survived due to traits that are letting them survive those treatments. Those survivors are multiplying and passing on their resistance. And after repeated spraying of the same type of fungicide or the same type of mode of action, that resistant fungus can become dominant. And so that renders the treatment being ineffective. And this is a common risk of banana production, especially under these ideal conditions, because bananas are the way they're grown is really this perfect storm for disease resistance development. And so again, you have that single cultivar. So you have the Cavendish of being genetically similar to each other. You have very hot, humid, rainy environments. So ideal conditions for fungal diseases to grow quickly and develop that resistance potentially quickly. And you have the crop, which is a perennial crop. So it's always there. The host is always present to be able to host that disease development. So I wanted to go into a little bit more detail on modes of action of plant protection products or pesticides. And so pesticides are generally classified by the type of pest they control. So insecticides, herbicides, fungicides, bactericides, and they're working by either targeting biologically or physically a mechanism in the pests and either cause mortality, will stop their reproduction, or will repel them. And that is the mode of action, what causing that. And so it's either working through direct contact or systemically within the plant. And just to give an example here, I have a fungicidal biopesticide that its mode of action is working by membrane disruption. And so hopefully you can see my mouse here, but you have the phospholipid bilayer of the fungal cell that is causing the disease. And then in this biopesticide, you have what's called a lipopeptide, and it's actually mimicking that membrane phospholipid right here. It's able to puncture into that phospholipid bilayer and cause a membrane disruption. And then we see what the effects are in the image below, where you have a healthy, thriving fungal disease on the left-hand side that hasn't been treated, and then you have the fungal disease that's been treated with the biopesticide. So you see that it's collapsed there because of the membrane disruption. So giving an example of mode of action. And to a grower or a farmer, this information is really important to be able to know how to rotate these different types of products. And so this is giving an example again of a banana plantation where essentially anything below this line is considered pretty good in terms of disease presence. So anything above it would be a plantation that wasn't particularly thriving very well. But that's because of the ability and the information on the mode of action, where you might have the same fungicide, fungicide one here. However, it is being rotated with some other fungicides that have different modes of action, and therefore the resistance is able to be managed. And so we call this a program, and really, in bananas, but really in any crop and with any use of pesticides, be it a herbicide, fungicide, bactericide, insecticide, it's always important to keep the mode of action and keep this rotation partner in mind. Lastly, before I pass it over to Graham, we talked about mode of action, but also formulations are something that's really important when it comes to pesticide products. And so, what is a formulation? A formulation is a mixture of active and inactive, or you may have seen inert ingredients. The active ingredient is really the chemical or the biological substance in that pesticide that is acting on it. So it's the one that's actually, causing the mortality, controlling, repelling, or suppressing that target pest. The inactive ingredients in the product are really to help the active ingredient work more effectively or the product to be applied in a safer way. And so examples could be, it's helping the product to be mixed with water. Maybe it's helping, again, in the case of bananas, you see rainy, in this case, conditions that these plants are being grown under. So the formulation can really help it to spread or stick on the plants. Another example, stability during storage, maybe better handling and application. And so that's what those inactive ingredients are really there to support for. And depending on the formulation type, it's also really important to know that because it helps inform mixing order in terms of, how the product is to be mixed and compatibility, water quality, how much you might need to agitate it, what adjuvants you might need to consider adding to it. And therefore, a lot of work really goes into the research and constructing that formulation, and also the development work that will be done when the pesticide is actually going out into field trials. So with that, hopefully you got a good overview of what modes of action and product formulations are. And now I'll pass the screen over. I'll stop sharing for a minute and pass it over to Graham.
That's super. Thanks, Sarah. That should have given you a really good idea, using bananas as an example crop, of why we might be really interested in these products, and why mode of action and resistance management is important, and why the formulation is important. But what do you see as a farmer, as a grower? Well, you're going to buy a container that's got a label on it. So here's just a few examples. Gives you a sense of, there's quite a lot of information on here presented in a particular way, but let's look at this in a little bit more detail. I'm just going to home in on mode of action and formulation. So here we've got one particular product, Amistar, and we can see here this quite prominent block that says it's a group 11 fungicide. In the text underneath, we also see this piece here talking about it being a suspension concentrate. So that's the formulation type that Sarah referred to. Group 11 fungicide, so that's the category of its mode of action. And then we've also got a bit of information next to this here that says how much of this particular thing, azoxystrobin, is in the product. That's the active substance. So this particular product has got a single active ingredient. Other products might have two or more. And being able to work with these becomes much easier if we can lift them off the paper and not just have them as slabs of text, but turn them into something that is more digitized. That's the aim of what we're talking about here. We want to have this as something where we've got a more consistent piece of controlled vocabulary. It's available digitally that we can carry into software systems. It's not just that we might be interested in, but this is just a step back and a step down into a huge amount of detail that is present on labels. So clearly, cartoon style representation of all the different subdomains of information on a label. There's a lot of information on a label, a lot. Typically, these labels are not just a little panel on the front and a little panel on the back. They often come with a little fold-out booklet. Some of the text is quite small, and all of it's there because it's considered important. So we'd be interested in working through more of this information in future. But that's a lot to do. We don't feel that it's smart to go after all of it in one go. So we're going to go after it step by step. And we're going to follow the lead of the high priority recommendations that came out of the strategic advisory group. So that's what TC347 is making use of. We've got product label as one of those, but as I've just shown you, there's a lot on a product label. So we're starting with a couple of simpler things. So the mode of action and the formulation areas that Sarah's pointed us towards, they are very important parts of the product, but we think that they're a simpler place to start. The building blocks of that complete label. So they align with what we're looking for from all these recommendations. And they're pieces that, a bit like a jigsaw, can begin to fit together with other things that we might see here, crops, units of measure, and so on, that can build up to eventually give us a complete product label. So let's look at one of those. Let's look at mode of action. I'm starting again with this particular product I used. So it's a group 11 fungicide. This has got a meaning, and the meaning ties into this splendid thing that you can see on the left of the screen. It's a poster. It's the sort of poster that scientists have on their wall. As a kid, you might have had a poster of some favorite film star or pop star on your wall. Scientists do the same sort of thing, but they tend to have posters like this of weird bits of chemistry and examples of how these bits of chemistry work and the classifications. Quite fun to look at if you're a chemist. I'm a chemist once, and I'm interested in this one in particular because I knew the chemist who, in fact, came up with azoxystrobin. I've worked with them a little bit, so that's a fun connection for me. And you can see here there's part of this giant poster that gives us everything that's in group 11. You can see azoxystrobin, that's our active ingredient, picked out. So that all ties up. So we've got a group for our fungicide. But Sarah also talked about the need to alternate or vary the different fungicides being used to avoid the buildup of resistance. So if you were working with a crop like bananas, you wouldn't keep using a group 11 fungicide. You'd know that you'd need to switch. The label would tell you that you'd need to switch. So you'd need to be looking for something else. Maybe you could switch to the biopesticide that Sarah pointed us to. And here it is. It's got a different group, BM02, rather than group 11, there in the lower left of the poster. So potentially you could switch from a group 11 to a BM02, maybe back again, maybe onto a third group. That's where some expert knowledge of what's best for your crop, your setting, and perhaps what's going on with disease pressure in your area would better inform you. But using mode of action as a clear tool to help you with that decision. So that's why this is a really important thing to carry forward as a piece of controlled vocabulary and a data structure. And then the formulations. So we saw a tiny bit on that azoxystrobin label. Here are little snippets of some of the others that we had on that slide a few slides back. Clearly, we've got things here in a few different languages because labels are used in countries all the way around the world. But you get the same sort of pattern. They're calling out the active ingredients and how much of the active ingredients are present in those products. So that's often what's called out in a crop protection product. Sometimes you'll also see other notes of other ingredients listed, but you will always get those active ingredients listed. The second part that we often see either written out in full, something like suspension concentrate, or possibly as a couple of letters, an abbreviation for the formulation code, SL or EG or SC, written either in a body of text or called out perhaps just under that formulation table. These are all giving us important pieces of information, but they're all there in amongst that other large pile of information. So these are things that it's worth us digitizing, putting into an information structure and making available as something that is machine readable, machine actionable to support the operations, for example, on a farm or some other setting that can take advantage of the formulation type, the other formulation information for managing tank mix or other activities, or looking back to mode of action for managing that resistance piece and keeping track of what's been applied, how much of each active has been applied, and when it's the right time to switch. Clearly, these are well-defined pieces of information, and we're getting these from particular sources. So here we've got scientists like to have a technical monograph. Here we've got a technical monograph that describes all these formulation classes. The mode of action for the formulation product, that came from something called the Fungicide Resistance Action Committee. We've got similar specialist groups, action committees for insecticides and herbicides. They manage groupings, similar groupings for herbicides and similar groupings for insecticides. So what we've got here are two areas of quite complex labels that we can pick out and work on. They're aligned with the strategic roadmap of TC347. The information is currently managed by specialist expert groups. We can tap into, for example, the names of active chemical substances, because those are essentially typically managed through another ISO team. And we've already got information structures that we could make use of for building a data structure for these two things. We could look at Ag Gateway's ADAPT framework. I'm familiar with the CropLife Europe AgriGuide label data model that contains both these things. So we've got good places to look for a draft. We've got well-managed information coming from these expert groups, and there's a good need to digitize these, capture them, and make them available for farmers and growers. I'll wrap up this piece here, and I'll hand over now to Stuart.
So good morning, good afternoon, good evening, everyone. My name is Stuart Ray. I'm the convener of Working Group 1, Agri-Semantics, in TC 347. So I'm here specifically because the remit of the Agri-Semantics group is taking on work like this. So if you hit the next slide for me, Graham, please. So as Graham pointed out in some of his slides, the SAG, the Special Advisor Group on Smart Farming, their final report laid out some low-hanging fruit of vocabularies that they felt were ideal to start with and foundational in the agricultural agri-food domain. We began work with the TC as ad hoc group 2, looking at crop. And we brought that work sufficiently along that we've been able to bring forward a working draft of a new standard for defining crop. And that resulted in the creation of Working Group 1. Now, things have gone into overdrive, and there are a number of people coming forward interested in bringing other pieces of this puzzle into play in doing the work. Graham and Sarah are excellent examples of people who are engaged and interested and willing to help out in doing this. So I'm showing you this for a particular reason, and that reason is these vocabularies were identified in the SAG report because they're kind of commonly agreed to be important, and they're commonly agreed to have, some already existing good things. Already existing good implementations. And our work is really going to be about shepherding that stuff into a stable format that we can manage long term. So mode of action and formulation are excellent additions to that work. You see that there are other boxes here, and we're definitely going to tackle those. But, pest and phenological stage have a level of complexity that I think are above, mode of action and formulation. And so we're starting, at places where people that expressed interest come forward and make proposals to do. So it's not just throwing a proposal over the fence. In fact, we have a process. And part of that process is what you're observing right now, the webinar. This is a mechanism that we use to help communicate to all the people that are interested and involved, all the delegates within the TC, what we're trying to do and specifically why. So be advised, if you're interested in taking on some of this work, this is part of the process. Being able to explain to a group of interested peers what we want to do and why. Then we get to making the proposal. So next slide, please. What are we proposing here? Well, we have to create a preliminary work item that lists out what we're going to tackle. And for these, for mode of action and for formulation, we're going to tackle this by placing the work within the 34705 series. Now, 34705 is the designator that started for the series within Working Group 1. We have Part 2, that is the crop, and that's under active development. Part 1 will be a generalized framework that hasn't been started yet, a description of how we decompose vocabularies and especially how we manage and curate them. But this will be part of that series. Whether it will be 34705-3 or 4, we don't know yet. We've got some other stuff in flight, one of which is unit of measure, which I'm sure we'll be talking about some more later. But this work will include working with the resistant action committees to set up how, as changes occur, they get funneled in and we can, put those changes into the maintenance agency that we have set up for managing and curating these vocabularies long term. Further, we'll continue discussions within Working Group 1 about exactly how to handle formulation codes and formulations, right? We're not quite sure yet whether they'll be part of the 3705 series, okay, because it's not necessarily just a flat list of things. The formulation codes are, but the formulations themselves about how to set up the units of measure and the quantities and the active ingredients, all of that's going to take a little bit more modeling, not different than what we've done with crop. So we've got a lot to do here. And what you're seeing now is kind of a preview of the work to come. So I would like to extend a personal invitation to everybody seeing this. Come participate. Help us drive this work forward. And with that, I'm going to pass it to our chair, Andres Ferreira, to tell you how to come participate.
Thank you, Stuart. Can we move to the next slide, please? In TC 347, most of the work happens online. Our ad hoc groups, advisory groups, and working groups have met online so far, and will likely start having some meetings that are in-person plenaries. But in general, we have two kinds of meetings, the plenary meetings and the working meetings. The plenary meetings happen twice a year. One of those is in person, one of those is virtual, as you can see there. The next plenary is in October. It's going to be online, and that's a good opportunity to catch up on everything that's going on in the committee and how the different initiatives fit together. The working groups, ad hoc groups, and advisory groups, like I said, meet more often, but they set their own schedule and they always meet online. There's two ways in which you can get involved to contribute to TC 347. One way is through your national standards body. That allows you to participate directly in the work, and you can help your country vote on the different initiatives, the different ballots, like the one I just mentioned in the chat. These ballots are handled in each country by the National Mirror Committee, as they're called, and that National Mirror Committee votes yes, no, etc., based on the input of all the experts in that National Mirror Committee. When you participate through your national standards body, you are a member of that national merit committee. You help steer the boat at both the sort of macro level with these ballots and at the micro level, working inside the projects to come up with those standards. If you instead participate through a liaison organization, you do that within the working groups, and you have a voice everywhere, but you don't vote. Last but not least, there's many ways of getting in touch with us. One is through that info email. Another is to email me directly. We have a LinkedIn page. We have an ISO page. We have a new committee page and so forth. A YouTube channel. There's many ways of getting material from us, right? But let's transition now to some questions. Now, I don't think I've seen any questions in the chat yet. There's some comments about bananas and from Emilio in regarding the Canary Islands and the problems they have with insects and so forth, where the considerations that Sarah and Graham were making about resistance management are equally applicable, of course. Insects and weeds also develop resistance to chemicals, right? So let me throw out a question. Let's see. Let's throw some I don't know strong words here. So Sarah and Graham, the world is moving away from pesticides. Why are you trying to make it easier to use them?
Who wants
Yes.
to go first on that one?
I can take a stab. Yeah. For me, a lot of this and everything about, really understanding controlled vocabularies and how we can represent things like modes of action and formulations, as we've talked about in today's webinar, is really about informing farmers to, be able to better select the right product for the right target, using it at the right time and in the right amount. And so it's really about stewardship. So crops all around the world, no matter if it's an organic crop or it's a conventional crop, utilize pesticides. And so pesticides and agricultural pesticides are an important part of our food security nationally and internationally. We use bananas as an example today, but think about everything you eat requires the use of pesticides to grow. So it's not about enabling more and more. It's really about enabling pesticides to be used in the right way. And so this is what this sort of information will start to help to do. We can also think about different ways that people are learning to apply, it's coming in the future, robots, sense and act systems, different ways of precision and targeted application. And so this will also enable these types of treatment. So I don't know, Graham, what else you might want to add, because I know there's a lot to discuss there.
Just a little bit I'd add is focusing on the digitization. So what we've talked about here is not simply how to point to a paper label and say, there's a thing, that's mode of action. There's another thing, that's a formulation type. We want to digitize those. We want to do it to help support people be better stewards of these products by making it easier for them to find the information they need. So maybe by digitizing, we can show them just what they need at the right time. If all you're doing is storing a box full of products, you probably don't need to know a huge amount about exactly how to tank mix it and apply it in a field in 4 or 5 weeks' time. But you might want to find the piece of information that tells you what personal protection equipment you should be wearing. That's where targeted digitization could help. And by making this digitized information machine readable and machine actionable, then we could tie in with the emerging more modern ways of precision application, or use of drones, or use of robotic or semi-robotic equipment. All of that becomes more robustly achievable rather than relying on a human somewhere in the chain to retype something that they've read off a paper label.
I think that's a point worth making, and it ties into a comment that that we have from one of our participants, also Andrew, which is that having the data available in a machine actionable way, it lets you implement tools that can help farmers manage the complexity of it all, right? On one hand, in many jurisdictions, they're increasingly being asked to record what they do, as Andrew said. And also, the fact that you can make tools that can take, say, a planned application and say, wait, you're about to exceed your active ingredient load, or you're about to double down on the same mode of action. Why don't you change it? That can really help protect the farmer from some problems that we've been having systemically as an industry for a long time, right? So, thank you. Those are good responses. Then another one. You mentioned, Sarah, you mentioned biologicals, right? So you mentioned a biological product. Do they have modes of action too? What's your idea of what to do with biologicals in TC347?
Yeah, biologicals. So we gave an example of a mode of action of a biological of a membrane disruptor, for example. So that's the mode of action example that we talked about today. And as Graham mentioned and showed in the FRAC poster, that's represented in the biologicals with multiple modes of action category. So that's that BM02. And you'll see, the organism, so the scientific name or the ISO name, along with the FRAC code. And so biologicals are an important part, like we talked about, of a rotation program. And so really understanding, what the mode of action of any pesticide, including a biological, is really important to this discussion, since, as we mentioned, it really helps inform these different types of programs that are really designed to manage resistance and effectively treat the pest of the crop that is present. And so I don't know if you had um, a different thought or a different question, Andres, that I could go into more detail about there.
Graham, anything from you?
So just the tiniest of builds, we don't have to do the extra work because the expert groups, these resistance action committees, have already done the hard thinking and worked out where to fit biologicals into their great schemes on these big posters. And by the way, anybody who doesn't have an office, you can always put them on your bedroom wall. They're great posters. They're marvelous. But they fit in. They fit into part of the same scheme. So exactly as Sarah says, when you need to switch to something different, they're available as one of the options that you could take to switch to a different group, a different category of fungicide, for example.
I think that's just to double down on what Graham's saying. The standards, the work that's being brought forward here isn't about dictating or defining how modes of action are classified and created, or the mechanisms behind how the action committees do their job. This is really focused on how do we kind of codify this? How do we make this available in a very semantically rich way? in a curated way to the industry as a whole. So building not only on what does it look like data structure wise, but also, hey, we're already setting up these processes to make this available to the industry. Let's do this for a number of controlled vocabularies. And we've
And
got a lot of traffic in the chat now.
yeah, so Nina Hurd, who is I describe her as product label royalty. She asked a question. Will the ISO standards, once developed and agreed upon, be incorporated into the current pesticide label digitization efforts such as AgriGuide? And Jean-Christophe brings up that, hey, this sort of thing is going to happen in the AgriGuide platform, how to avoid double work and formats for machine readable labels. Jean-Christophe, I'd say join the effort, right? Because the result here is going to be an international standard, which will enable broad interoperability, right? And indeed saving of a lot of effort. It's an important thing to always be looking for opportunities um, to work less, right? And we have people in TC 347 that are very active in Crop Life Europe, and these kinds of conversations are going on. Graham, do you want to elaborate on that a little bit?
So I can try and keep it brief so we can come to some of the other comments. The simple answer to Nina's question is yes, we will be incorporating it. And yes, we'll avoid double work because we don't want these to be two different things. We want them to be either the same or aligned. An implemented data structure isn't necessarily exactly the same as something you write in a standard, but it's not beyond the wit of those of us who will be working in WG1 to get these things aligned in a reasonable way, because we want these things to be suitably aligned and reusable globally, not just in a relatively narrow silo. I'm really keen that what we create here is a piece of data as infrastructure. So going back to Stuart's point, essentially we're building a bit of plumbing between the experts who are creating things and building beautiful posters and turning it into a way of flowing that data through a piece of data infrastructure into the software that might well make use of it and to make it easier for the people to get to it, but aligned in all the places that we're doing this.
So Nina's comments, Jean-Christophe's comments, these are I think answered, and Sarah provided a link to AgriGuide for folks who don't know what that is. And then Glenn brings up a question about what about other organic agriculture labeled chemicals that are not biological. That's a good question, and it has different aspects to the answer. I'll leave the mode of action part of the answer to Sarah and Graham, but regarding the idea of whether we would have those things as part of our vocabularies, the answer is certainly yes, right? We're looking for a way to align with ISO Technical Committee 81, which has a vocabulary of active ingredients that have been used a lot in the industry and that the manufacturers contribute to as a way of maybe managing our active ingredients. But we certainly need a way to be able to deal with other things like, sulfur and copper sulfate and things like that that aren't necessarily active ingredients in the classic sense of the word. Graham, or Sarah, any builds from you?
I think you've said it, Andres. I think they are considered active. Clearly, they have some activity. That's why people use them.
Mm.
They've got uh, well, some of them their use goes back into antiquity. So there's there's an age to them there. They're fairly well understood. They're easy to point to. They're simple enough that you don't need typically a more complex way of naming and labeling them, but you can fit them into the same sort of scheme and identify how to use them or not use them as part of a rotational scheme.
Yeah, and maybe I would just have a tiny build on that. What we're really talking about, like Stuart and others have mentioned, is leveraging the good work that these resistance action committees are already doing. So we have the technical expertise there. We have the representation in really nice posters that Graham, talked about. The scientists hanging on their walls instead of the other magazines, for example. And so that sort of work is really able to be leveraged. So absolutely, if it has a mode of action and is represented in one of these resistance action committees with a code, that code would appear on the label. And we're really talking about, making that leveraging the work and making that interoperable with what we're doing in a machine readable and actionable way. And so just looking at, we used membrane disruption as an example of a mode of action of a biological. There are other chemicals that are, not labeled for organic production that are also appearing in those resistance action committees with codes. And so those would apply. And absolutely other products that are labeled for organic use, like copper, they appear in the list. For example, MO1 is the FRAC code for copper, and so it's a different mode of action code, right, than the BMO2 that we were talking about, but it has a code. And so if it has a code, this is something that we would be talking about this sort of work on.
And just for clarity, we're not seeking to take over kind of active development or management of that work from those action committees or anything like that. This is strictly kind of standardizing how we can make that available to the industry in a, as Graham pointed out, machine readable and machine actionable way. So I want to make
Interoperable way
sure,
as well.
yeah, I want to make sure that there's no misunderstanding here. We're not seeking to take anybody's lunch money or displace them from their place at the table. All of this will still be managed by the relevant outside organizations. This is really about facilitating the digitization and the interoperability that TC 347's mandate dictates.
And we have a question from Jean-Christophe. Graham, would you go back to the snake picture, Stewart's snake? Jean-Christophe, these things like crops and field operations and pests and phenological stages and modes of action and active ingredients and so forth are pieces that were identified by a group called the ISO Strategic Advisory Group for Smart Farming as things that needed to be standardized in order to be able to get to the point where one could do automated label checking and things like that. The kinds of use cases like adding up active ingredients and supporting resistance management and so forth, right? Some of these are being actively worked on right now, like crops is something for which we already have a draft. And there's work on field operations in one of our liaison organizations that's nearly done. And we are about to ballot work on unit of measure codes as well coming out this week and so forth. So it's not like modes of action and formulation are just arbitrary. We're just filling in those blanks. And in some cases they don't have to be in order. It depends in great part on who's willing to advance this work and who gets excited about moving a part forward, and folks who get excited to support it, right? But those are necessary. They're certainly not sufficient to be able to do the things that we want to enable. Stuart, Sarah, Graham, you guys want to build on that?
I think it's really helpful to have an expert group creating some pieces, already publishing something, and with many years' experience of doing the thinking and the managing and the discussing in committees and then publishing the information. That puts many of these areas in a really, really good spot. And we don't have to scratch our heads and work hard to work out where the edges of the boxes are necessarily. But we do need to then be able to work out how to channel those sets of information through from something that is typically being shared as a PDF or some other relatively flat style information to something that can then be reused easily by pieces of software, machine readable, interoperable, and so on.
And as we're going along, we're also testing some of the fundamental assumptions about the work we're doing, like if our componentized semantic model can hold up to the challenges of dealing with each one of these things, right? And so like Nina's saying, we're sort of coming in from the edges. Crop was a good place to start because it was easy to communicate the value of it, and there wasn't a clear solution to it because it's a lot more complicated than meets the eye. And so these other things, we're trying to apply this pattern that was developed there to all these other little problems as we sort of spiral into the more complex things like defining products and use restrictions and product labels. Okay, so we're at time. I thank you very much for your questions and your comments. I hope that you will be interested in joining this effort. In a few hours, I think we're going to have this webinar in our YouTube channel, and over the next few days, we'll clean it up and remove some of the ums and ahs that I certainly am quite prone to using. And we'll have the ballot for the PWI for this out very soon because we talked about it at the plenary a bit and so forth. So there's little point in waiting. So this will likely be out this week as well. I want to thank our presenters. I want to thank all of you who came. There's been a good crowd, a good mix between various usual suspects within TC347's family and new people. Thank you all. Have a great rest of your day.